So hello everyone, today we are going to build a complete machine learning model from scratch using a Python. We will be using the famous dataset to predict the species of flower based on its measurement. First, we will import NumPy libraries by writing import numpy and NumPy as a NP. We are importing the NumPy library, which is the absolute foundation for numerical computing in Python. Next, we will import Pandas library by returning import Pandas as PD. Pandas is the go-to library for data manipulation and analysis. It gives a powerful object called a data frame. Uh, Next, we will import Scikit-learn dataset by returning from Scikit-learn datasets import load iris. Here we are inputting a specific function load iris from Scikit-learn, uh, which is the most popular machine learning library in Python. This function allows us to easily load the built-in iris flower dataset without having to download any files, and we'll go through our code easily. So here I am writing the next of I will write from sklearn dot model selection import train test split. This is a crucial one. This function will help us split our data into two parts, one for training our model and another for testing how will it perform. This is a fundamental step in machine learning to prevent our model from cheating. The next uh, I will writing third importing library, which is from sklearn dot preprocessing import standard scalar. From we import standard scalar to standardize our data. This process rescales our features like petal length and sepal width, so they all have a similar scale. This is important for many algorithms, including the one we are using today, because it prevents features with large values from unfairly dominating the model. Next, I will return from sklearn.neighbors input KNN neighbors classifier, which is this is the star of our show. We are inputting the k nearest neighbor classifier. This is the actual machine learning algorithm we'll use to make predictions. Then next I will return from sklearn.matrix import accuracy score classification report and confusion matrix. From sklearn.matrix import, we import some function to evaluate our model. Accuracy score tells us the simplest thing, what percentage of prediction were correct. Classification report gives us a more detailed breakdown of performance, and confusion matrix shows us exactly where our model got things right and where it got confused. For saving time. Then I will return the next step just clicking undo. So it will save our lot of time, and I will explain the whole code as it is, which will help you to understand. And here I return iris equals to load iris. We call the load iris function we imported earlier and stored the entire dataset in a variable called iris. Here I return next x equals to iris dot data, y equals to iris dot target. In machine learning is the standard name for our feature. Next I return print feature name iris feature names. Next print target names and iris target names. Here these lines are for our own understanding. We are printing the names of our feature and the names of the target classes. Next I will return x train, x test, y train, y test, train test split, x y test size equals to 0.2, random static equals to 42. This is a single line, does a lot. We pass our features x and our target y to train test split function. Next I return scalar equals to standard scalar. First we create an instance of standard scalar object which we will call scalar. Next I return xtrain equals to scalar dot fit transform xtrain. This is a two-step process in one command. Next I return xtest scalar transform xtest. This is the critical point. Notice we only use transform on the test data, not fit transform. Next I write KNN negbur as classifier and negburs equals to 5. We are creating our KNN model. The most important parameter here is n negburs, which we are setting to 5. Next I write KNN fit xtrain ytrain. This is the training step. We call the fit method and give it our training feature. Next I write y pred equals to KNN predict xtest. We call the predict method on our trained KNN model and pass it our test feature. Next I write print n model accuracy score y test y pred. Here we use accuracy score function. Next I write print n classification report n classification report y test y pred target m. The classification report gives us a much more detailed breakdown. It shows us metrics like precision, recall, and F1 score. Next I return print n confusion matrix and confusion matrix y test y pred gives us a table that shows us our correct prediction versus our incorrect ones. It's a great way to visualize exactly which flower species our model is confusing with another. Next I write print and testing different k values from k in range 111. We are starting a loop that will iterate through a number from 1 to 10. Each number will be our k value. Next I return model equals to k in negbur classifier and negbur is equals to k. Inside the loop for each iteration we create a brand new KNN model, this time setting n negburs to current value of k from our loop. Next I return model dot fit xtrain ytrain. Model xtrain ytrain, we train this new model on the same training data. Next score equals to model dot score xtest ytest. The score function method is a convenient shortcut that makes prediction on the test set and calculate the accuracy all in one step. Finally, we print the value of k we just tested and its corresponding accuracy score formatted to 2 decimal places. By looking at this list, we can easily see which value of k gives us the best performance. Now I will show you the output of this model in the terminal. Here I will return the command which is in yellow color. By writing this we will give the output of our model. Here this showing. So yes, we complete this.